Okay, good morning everyone. My name is Aliviada and I'm from the Econ department. And today, as I put it on the board, we're going to learn how to use the Lagrangian multiplier method in order to solve a constraint optimization problem. Now, before I start, I'd like to ask you, what do you think about our needs and wants? Are they limited or unlimited?
Limited.
Needs are limited, wants are unlimited.
Okay, so let's say that we want to buy a lot of, you're a girl, you want to buy a lot of clothes and shoes and bags, etc., etc. But you have unlimited wants, right?
Yes, I do.
Okay.
Shiny things. I love shiny things.
Okay, but you're a graduate student at Drexel, and unfortunately your budget is constrained, right? Drexel University pays you a certain amount, A, per month. Let's not disclose that. And that is what should constrain your wants, right? Now, let me write the budget constraint as A, which is the total amount that we're going to get every month, is equal to the rent. As if you have a look there, we have R, which is again a constant. Our rent doesn't change, hopefully. And plus price of food times quantity of food. PF stands for price of food, then X stands for quantity of food. Plus, I just listed their clothes, but you can list anything else. Price of clothes times Y, which is quantity. Okay? Now, to make this easier, I set A minus R, since they're both constant, is equal to B. And so our budget constraint will be B, PF times X plus PC times Y. Okay? And now, the goal is to maximize our utility function, which again I assume, because we love to assume stuff. So I assume to be ln x plus ln y, subject to this constraint. Okay? In order to understand how the Lagrangian multiplier method works, I'll go step by step. And please, I encourage you to ask questions, but save them for the end because I have a very limited time right now. So, step one was setting the goal, okay? And writing the Lagrangian equation, we'll note it by capital L, stands for the Lagrangian equation, is equal to utility function ln x plus ln y plus lambda, which here stands for the Lagrangian multiplier, okay? I abbreviated a little bit. Multiplier times, substitute for the budget constraint in the form B minus PF times X minus BC times Y, okay? Can I re-erase this part? Yes, that's okay. Okay. This is the first step. Once we've set our Lagrangian equation, we can go on with the second step, which is we want to set our first order conditions. We have two variables, x and y, and in order to set our first order condition, we find the partial derivative of the Lagrangian equation with respect to x is equal to 1 over x minus PF times lambda, and the same for y is equal to 1 over y minus PC times lambda. Now, the third step would be to express x in terms of y or y in terms of x. Okay? We find that from this equation, 1 over x is equal to lambda times pf, and 1 over y is equal to lambda times py. And